So the topic of today is tables. This is chapter 6 of our book, so please read chapter 6. All the first few ones are pretty short. This one is going to take some more time. So I want to go through and have a lot of examples. But yeah, we know how to get the documentation pages. That's very important. That is in our Jupyter Lab little link right here. And then you scroll down to these 2 Python reference pages. I've got both of them open, and I'll just show you the same stuff in both of them as we learn new things. But yeah, inside of a table, we've got a bunch of things that we can do. We know we can read a table from a file. We've got some other things that we talked about, but like select. We talked about select. We talked about drop. Get me some columns, get rid of some columns. We talked about sort. We talked about .where for a little bit. All those things, they should be somewhat familiar, but we're going to hit them hard in this chapter. All right, so yeah, table functions and methods, that would be this part of this page, the first page. We did .show, but yeah, there's a few different ones that we will learn. So, okay, I'm just going to go to Jupyter and have a bunch of demos of table stuff, and we'll go from there. All right, and you just shout out if you have questions. Let us talk about things. So let me open up Jupyter. Hopefully it is happy with me. And then that's us, and this is chapter 6. So I'll make a new file for chapter 6. Yeah, if you'd like, I will, let's see, for this section, at least today, I'm going to use one of our tables, and it's the cones.csv file. And then I might also get into Pokemon. For that, we're going to do more ourselves tomorrow. So yeah, if you'd like, you can click on the link that includes the data sets. That would be helpful if you want to follow along, or you just download my entire data sets file from our code from class. Either way, but here, let's make a new file for today, and we'll import all of the data science library. So this is we're going to say this forever until the end of time now. This is what we did last time at the start. From data science, import everything. The star means everything. Import star, and that just gives us access to all the data science functions, including the function that makes a table and that reads a table from a file. So let's do all that, and yeah, the simplest table that I could possibly make for you is the empty table. So here, if you just say table and call it like a function, that makes a new table for you, but the table holds nothing. So if I do Shift-Enter, it will eventually display that table to me. It looks like it's still including the library right now. There it goes. So it's displaying the empty table to me. Isn't that fun? So that's nothing in there, but it's useful still to be able to make that empty table because you can add rows to it. And add columns to it one at a time, okay? So usually we're going to think about tables in terms of their columns. Eventually we'll learn how to add rows at a time, but usually we're going to add stuff in column form. Am I in the right folder right now? Yes. So here's kind of what a table looks like from the data science library's perspective. It's always got a bunch of columns, and they are labeled. So label 1, label 2, label 3, for as many as you have. And these going, let's say we've got some data, I don't know, A, B, C, D, E, F, G, H, I. And so these are our rows of our table. And these are the columns of our table. And I got this mixed up so much when I was undergrad. I just want to make sure we're all on the same page. So column, I guess you can think of column like that Greek Parthenon, whatever the thing is. The columns are going up and down. Yeah. Columns are going up and down. They are vertical things. And then rows, they're I don't know. It's like you're rowing in a canoe. Horizontal. So, okay. Yeah. Let us start with the empty table and add a column to the empty table to make a table with one column. That's there's a function called withColumn. So, a couple places where that is. You give me a table, .withColumn. I give it a name, give a label for that column. I give all the values that live within that column. And you can do also, there's withColumns, plural, and you give a bunch of names and values so you can make a big table all at once. So there's that one, and then I'm sure it's here somewhere too. Yeah, with a column. So wherever you'd like, look at those. So name is a string, it's a stir for the name of the column, and then values is going to be an array of the things that are going in that column. So here, I want to make an empty table. So table, parenthesis, parenthesis. And then I'll say, hey, empty table, I'd like to add a column to you, which is going to end up being a table with one column, right? With column, and then I'll just make a table of people right now, or animals, because I'll put my cat in the table. So the column label is going to be name, and then the things that are in the column are names of things. Make array, and it's going to be an array of stuff. So you say make array, and then you give the things in the order that you want them. So we'll have me, we'll have my cat, and then we'll have the other computer science professor here, Bill Kearney. And so if I do Shift Enter, this makes a new table, right? It starts with the empty table, and then we're attaching to that one column, and the column's name is called name with capital N. And then the elements of that column, the items in it are me, my cat, and Bill. Okay? Any questions about that? So you can build up. You can have an existing table, like the empty one, and you can start adding stuff too. Okay? Questions about that? Does that make enough sense? Need more water to say. But yeah, not too bad, I hope. So yeah, there's a with column, and there's also with columns if you want to build a big table all at once. So like instead of doing it this way, table with one column, you can say table.with columns, and then you just give a bunch of name values until you're done, until you got as many as you want. So I'll try to make this pretty by making multiple lines, but you could put this all on the same line if you wanted to. So all right, we'll keep the name column, and then I'll add another column called age, and the values there can be I am 33, my cat is 6, and I don't know how old Bill is, but he's at least 1 year older than me. So that can be our table. And me calling with columns like this, it didn't have to be like this. I'm just trying to make it pretty for us. I'm really like, you could just do it all in one line if you wanted to, but I'm just trying to make it pretty. So it really could have been like this, but that just gets disgusting and hard to read. Yeah? So it's just like I'm giving a bunch of things, but if you want, you can make it pretty and indent. So there's 4 arguments to this with columns. It's always going to be a multiple of 2. It's like column label, values for that column. Column label, values for that column. They're going to go in order, right? So the 33 is attached to me. The 6 is attached to Lonzo. Yeah? That's important. So that makes this table. Does that make sense? So there that one goes. And you better believe, like, that's a table. Just like if you read one, you can give it a name. You can say, like, this table is called people. And then you can have that for later and to do stuff with, and do like dot selects and things, and dot drops and dot sorts and stuff like that. It's like now you have it for later. All right, so you can give anything a name. And interestingly enough, you can, like you've got an existing table, you can do with columns again, right? With column, I don't know, who's the employer of these people? Of me, make an array, add the employers. Let's say my employer is Clovis Community College, my cat is unemployed, and then Bill also works for Clovis Community College. And remember that strings can be double quotes or single quotes. Doesn't matter. And so I'm attaching to that table a new column. Yeah, and so you can build up new stuff. You just got to get in the right order. You could say, though, if you're not really sure how many columns you're going to have, you can just like start with it with columns, and like this is fine too. You can still say with columns even if you only want to give one, but I guess it looks better to just say with column. With columns can have just one column if you'd like. It's fine to use the plural with columns and only add a single column. The reverse is not true. You can't say with column and then add multiple columns. Then that would get very angry. Okay. So yeah, there's that. So you can attach to existing tables, important. And this always, when you say with columns, it generates a new table. And so the people table did not change. So all of our table operations that I want to teach us are not going to mess with tables. They're always going to give us back new tables that we could then assign into new variables maybe, or update existing ones. So this one didn't do anything, didn't change. Okay. So yeah, I think that's what I wanted to say. That's how you build a table from scratch. Any questions about that?
I'm so sorry, I got stuck at like the first step.
Oh, sure.
No idea what I did wrong.
Scroll. Do you have an error message right now? Is it saying something?
says unterminated string literal detected.
Oh, okay, that means you didn't close a quote. Or maybe you put an apostrophe or something like that within a string and it didn't, like, it thought the string ended early, but here, I can come take a look. Got time to get it right.
This is what I have.
You need to close the name string. Name is just some text. You need to have to say name, quote, name, quote.
So, like that?
That's the
Thank
text
you.
of the, that is the name of the column. It's called name. Whenever you want to give text in Python, it's quoted. Yeah. Other questions? Okay. You can change the names of column labels, which is fun. That's called relabeled. You can say, you got a table and say dot relabeled. This is where these two pages, if they didn't get changed, differ. There's a dot relabel that this one talks about, and this one messes with the table. So I don't want to teach you that one. I don't like it. I like the ones that give you back a new table. So this one actually is going to modify the table. You say dot relabel. And so I would rather teach you this one, past tense, relabeled. It will give you back a new table with a label called, an old label called the new label. All right, so you give it the name of a label you want to change, give it the name you want to change it to, and then it will give you back a new table with those labels switched over. Okay. So I can say people dot relabeled, plural, or not plural, but past tense. And then let's rename like the age column to, I don't know, trips around the sun. Something like that. And so then that's giving me a new table with that age column changed to some new name, all right? Which is useful. Like, you remember the Pokemon table, everything was lowercase, like maybe you wanted to make it uppercase, who knows? So that's a thing. And again, this did not mess with the table. If I said dot relabel, it would have messed with the table, and that's not okay. I prefer it to give me back a new table. So we're going to do relabeled in this class. Okay, but yeah, I didn't change that one. Let's see what else. Are we ready for more options? I need to get to that eventually. But I think that's a good start. Are we ready for a different table? New stuff on a different table. So I'm gonna do like I'll do like a dividing line. If I go to the markdown mode, and I do 3 dashes, it makes a dividing line, which is fun for me. And so, okay, let me make a new table, and I'll read this one from a file. So in my data folder, I won't read the Pokemon one for once. I'll say table.read table, and you can say table parentheses dot read table, or it's quicker. You don't have to say the parentheses, actually. You can just say table by itself dot read table for special reasons, but either way would work. Less typing for me to do it this way, so I'll do it this way. That's how I've been doing it at least. So table.read underscore table, but it would have worked if I said this, empty table, read a table into you, I guess. But like table idea, let's get a table into you. And it's in my data folder, and it's called cones.csv. It's the ice cream cones ones. So that's the one I'm going to use today. And so if you're following along, you can go to the code from class and read that one in, or you just like, if you clicked on the link to get that temporary page with our data sets, you can change the pokemon.csv to cones.csv. And so it'll give me that table, and of course I can give it a name. I'll call it cones the variable. And so there's my table. It has, let's think about our terms, right? It's got 3 columns, flavor, color, and price. And it has 1, 2, 3, 4, 5, 6, 7 rows. And each row is meant to talk about one kind of ice cream cone. A row is like an individual in our data set. All right. And individuals don't have to just be people. So yeah, you can ask this table information about itself. For information about itself, you can ask for how many columns it has, how many rows it has. There are variables inside the table. It can be like table.numRows. It's not a function, it's just like a little variable within the variable. NumRows gives you how many rows there are. NumColumns gives you how many columns there are. And so I can say cones.numColumns. And this would be useful for like the Pokemon table where it's hard to see. But this one is clear. There's 3 columns, right? 3 columns. Flavor, color, and price. You can ask for the number of rows. How many things are in this table? There are 7 things, 7 ice cream cones. And then you can also ask for, give me every single column label. That's dot labels. If you ask to say the table, you say dot labels, cones dot labels. It gives me flavor, color, and price with parentheses. Think of that like an array, more or less. It's just an array in a different kind of format. But it's giving me a sequence of those labels in the order that they are in the table, because it could have been in a different order, right? So yeah, I think that's most things. That's like variables within the variable, which is interesting to think about. One of the things we talked about last time was I can go and get the contents of a column back out as the array, right? Because we know that's how we put them in. We can get them back out as an array as well. So like that's dot column. Let's try this one for once. So you can say table dot column, give the name of that column or the index of the column, which we'll get to in just a second. And that gives you back the array of the things that are in that column. All right. So if I've got my cones table, I can ask for like the price column, and I get back the array that holds all those numbers in that order. All right. So I can say cones dot give me the column called price, and then give me back that array of all of those values in the order that they are in the table. All right. And then you could do array stuff on it, like go find the max, sum them up, give me the average, all that fun stuff. Okay. But also, if you notice the documentation, it's saying column name or index. So I can give the string the name of the column, or I can give an int the index that column exists in the table. And I just want to remind you that indices start at 0 in Python land. All right, pretty much every programming language except for some really weird ones start at 0. All right, so we are going to try to figure out then what the price column is in terms of indices. Which one would it be? What index would be the price column if we know they start at 0? You see it? What's that?
Oh.
It goes flavor, color, price. So price is which column?
2.
Index 2. Does everybody see that? It's not 3, it's 2 because they start at 0. So I could have then said cones.column 2. And that one would have worked. Ta-da! So yeah, there's all those. What else? And then you know that you can go inside of an array and get a piece of it with indices as well, right? So you can go inside of the price column. It's like, here I am, I've got the price column. And let's say I wanted this $3.50. Which index of the array is the 350? 3.5, this one. Because you've got the rows, or the columns themselves can be indexed, and then this has an index too. So it's going to be 0, 1, 2, 3, right? Index 3. So all right, give me the price column, go to item 3. And that gives me this one because it's 0, 1, 2, 3 gives me that. Does that make sense? You can index into the arrays, of course, as well. So that's fun. And so like you can just keep going deeper. And that was array stuff. So if you want to go look at all that, that's probably array functions and methods. I was doing .item on an array because .column gave me that array, and then I can chain that on top of that. Give me the item in that array that you just gave me, Python. All right. Remember that they start at 0, very important. And yeah, you can just you can keep playing this game and go to item 0. If you want the 355, that's item 0, right? Remember that they start at 0. Important. Yeah, so here, here's my question for you. So we've got the cones table. Here it is. With this kind of syntax and style, I've got a question for you. Here's your question ice for the start of the day. And please help each other and talk about it. But try to calculate. Let's calculate the total price after sales tax. Because if you go to an ice cream shop, they're going to apply sales tax. So let's calculate the total price after applying. Let's say that it's 8.75% sales tax. I forget what it is in Fresno. I think it's more in Clovis now, which is weird, but they did that to the price column. Does that question make sense? So the price is not $3.55. Give me the total price, that plus the tax. Can you calculate that? for every single one of these, because you can get out the price column, right? Like this or this. And then you can start doing math on it, because if like you multiply it by 2, it's going to double everything. So try to get back a new array of the prices with the tax included. Does that question make sense? So yeah, give that a try. Help each other and ask me questions. And while you're thinking about it, I'm going to get more water real quick. What is the 6 tax? It could be 8.75. I don't know, but it something like that. Let's start with the price array. Get that column. And then what math are you going to do to get 8.75 sales tax out of the deal? So the total price, $355 plus the sales tax. $475 plus the sales tax. How would you calculate that for everybody at once? Give back the final array of those prices with tax. And if you get it early, maybe you can try rounding it, because I don't think it's going to be perfectly to cents, exact cent values. All right, friends. Did we get it? Any questions about how to get it? So let's see. Let's maybe work with, there's a couple options. We can like do the tax first and then kind of add it in. Maybe let's try that. So if I wanted the tax, I could go get the price column. So there it is. How can I apply 8.75% sales tax to all these values? What, I just multiply by something, right? What would I multiply by? That would be plus the tax. That's the other option. That's good. Yeah. But if I just wanted the tax by itself, I just multiply by 8.75%. So like 8.75 divided by 100. That would give me taxes for all those values. Does that make sense? And that the multiplication just kind of applies that that value into every piece of that existing price array, which is great. So I only have to say times one thing, and it multiplies it to all 7 things. That's really cool. So that's helpful. And like we can call that tax or something. tax equals that. And then we could return or give back tax plus those existing prices, right? So that's one way to do it. Does that make sense? Questions about that?
Just multiply by 1.0.
You absolutely could. So let's do that way too. Depends on how you want to think about it. Like, do you want to show anybody the tax first in the receipt or something, I guess is the question. So those are two competing options, and either one works just fine for answering this question. This is like option one. Option two is like you do it all at once. Times 1.0875, right? Get the same thing. Yeah. So either one works. You could also, if you remember last time, we talked about some other array operations. You can, if you include the NumPy library, there is a rounding that you can do to each element of the array. You can say np.round, give the array, and then give how many decimals you want to round every piece of it to. And that is great because these are not really prices right now. So we could say if we imported the NumPy library, this is option 2. Import NumPy as NP is how the cool kids do it. And then you say, you've got all this is what we have already. And if I say np.round that array, it'll just round it to whole numbers. But if I give a second argument to there, it would round it to the nearest 2 decimal places. And those are now prices. Those are now prices in cents, which is great. So that's pretty cool. Yeah, I think that's what I wanted to say. Are there any questions about that? A couple options. Fancier. You can get even fancier with the np.round stuff. All right. So yeah, let's do that, and let's add it back into the existing cones table. Let's be like, let's add like this column into the end of the cones table, like have a price with tax column additionally to all of these other things. So I don't know, let's have fun and like use variables. Let's be like the tax rate right now is 0.0875. That's 8.75%, right? And then okay, the tax is this. You multiply the prices times the tax, and this would make it easy to like change this to like Clovis's tax rate or whatever, because it's different than Fresno's. So times tax rate. And there's the tax column. So I still got that back. I haven't rounded it yet for a reason. I'll show you in a second. And then let's say we've got the cones table. Let's add a new column. And whenever you add a new column, I'll call it price with tax. You got to add just as many things as are in the table. But this is perfect because we're using a column with a table to make a new one. So this is totally fine. So I'm going to be like price plus tax is the tax plus cones dot give me column price. Yeah. And this, do you see what it's doing? It's calculating this array, which is more or less this one, is calculating that one, and it's adding it back in as a new column to the cones table. But it's not changing the table. This is always giving back a new table. But we've attached a new column with as many elements as we needed to put there. Just as many, just like we had before. There were 7 things, and I added that column with that name. Isn't that fun? So you can start attaching columns to your table by doing stuff with existing columns, and that becomes very powerful. And that's fun. Questions about how I did that? Yeah.
If you don't add like the price at the end, will just put it at the end automatically.
Which price? This price? Oh, then it would just have the tax in it only. Like this? Then it would just have the tax values. It's not the full price. Because this only calculates times the tax rate, not times 1.0875. If I put a 1 there, then it would have been fine. Yeah. So it just depends how I wanted to calculate it. It's like taxes only plus the existing price. This is how I did it for this example. But you could have totally did it option 2 way and added that column. Yeah. So you got competing options. There's usually a million ways to do the same thing in Python, and you just got to pick one, the one that works for you and your brain. Yeah. Other questions? All right. I didn't round because you can do a cool thing with tables. You can add formatters to columns. Let me show you that. So if you have a table named T, you can say set underscore format, and then you say name of a column, and then you replace this purple underline with one of these purple words. And there's others as you read through the book. But this will change the way the table displays the contents of that column, the array that makes up that column. It will not change the values. It will change the way it prints them out. All right, so it will do the rounding for you. There's a currency formatter, and like it'll round my numbers. It won't mess with them. If I ask for the column, it will give these values right back to me. But it will show them in a pretty way with a dollar sign and rounded and all that. So that is set underscore format. And it doesn't show up to me there, so it must be here. Set format. Oh, okay, it's just like, it's part of the textbook, I promise, but it's not in either of these. It's secret. So, I mean, that's why we're talking about it. So, okay, I say table. So, let me give this a name. Let's call it cones with tax. Unless they got rid of it with their new update, which I don't know if they did. Comes with tax, highly doubt it. Is that, so that's my table, and I can say dot set underscore format. Surely that exists, right? Okay, cool. Question mark. It does exist, so I can ask questions like, what do I do for this? How does it work? Pretty print format. So I say set format of the price with tax column. You'll learn more about this as you read the book. Apparently it's not in either of the documentation pages. And then you say currency formatter, because it's a type of currency. So this is just like a special variable that knows how to print dollars and things. So what this does is it changes the way the table prints this column, if that makes sense. It puts a little dollar sign, it rounds the values for you, but it did not change the contents of that column. It's just the view of it. So to help you see that, if I go and I say, hey, table, if you print out, by the way, it's always going to remember that format change. If I ask for the column called price with tax, I get the original unrounded values. So it's like all the secret stuff is still in there. It's just pretty printing it, is what we say. Okay, so that's pretty cool. What else? So let me show you some of the other formatters. There's a number formatter, there's a percent formatter, and there's more where that came from. So let's make, I don't know, for fun, let's make a new table, blank table. I'll add a column called X, and inside of that column, I'll put the values 1,000, 100,000, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 nines. And we'll figure out what that is. And I'm going to say to this table, set format, the X column with format it with the number formatter. And what that will do is it will like make it pretty. It will, is there a way to show this? I don't think I can break the line very easily, but I said, there's my table, and I said format with the number formatter, and it'll just put commas to make it easier to read what the numbers were. So this is apparently thousands, millions, billion. That was 9,999,999,000 million, 999,000, blah, blah, blah. So yeah, that's making it easy on us. Okay, so that's the number formatter. Again, the secret numbers, the array hasn't changed. Like you still have the numbers themselves, but the way it prints it is just pretty. And then finally, percent formatter is if you have fractions and you view them as percentages, then it will like multiply by 100 and put a percent sign at the end. So again, if I make a table with a column called X, and in that column, I'll put the values 0.5, so 50%. So 50%, 75%, 99.99%. And then I say set format the X column with the, well, by default, right? It's just those numbers. But if I say set format of the X column with not the number formatter, but the percent formatter, then it changes the 0.5 into 50%. I'm just going to show it to you in that way. So if you have percent values and you're treating them like percents, it will print them to you in a pretty way. But secretly, if you ask for the column, it will give you them as the fractions that they secretly are. Okay? That's just changing how you print and view the tables, like you give it to your boss and it looks nice, kind of. So yeah, I think that's those. That's what I wanted to say about those. Yeah, any questions about anything we've done so far? There's a lot of fun things going on. I need to call this chapter 6, by the way, don't I? Yeah, we're just following along. All this stuff is in the documentation page except for the format stuff. You'll read about it at least, but you can look at my code when I give it to you. Yeah, let's just remember some of the other things that we talked about before, the select, the drop, all that fun stuff. Just go over those quickly. So select, you give it column labels as strings. We can say all these words now, and it will give you back a table, a new table from the existing one with just those columns in just that exact order. So I can say, back to the cones table, let's say dot select. Oh gosh, what do I want to do? So, or maybe we'll do the cones with tax. We got more columns in the cones with tax table. So we'll say cones with tax dot select. Maybe I don't want to see the price anymore. Like I just want the final price, the one that I'm going to pay. So I can select out, and I don't care about the color. Let's say I care about the flavor, and then the final price with tax. That's all I want to see. I can select them out like that, and it will give me a new table based on the old one with just those columns. Yeah, so that's what select does. Remember that. Another fun thing, now that we know about indices, is when you do a select, you can also give indices. Each column is the column name as a string or the index, the integer index of the column. So instead of saying flavor and price with tax in my select, I could have said 0, right? Because flavor is column number 0. Could have said 0, and then price with tax is column number 0, 1, 2, 3, right? So I could have said select 0, 3. That also would have worked. And I get that. Same thing, right? And remember the subtle difference between selecting a single column. Select always gives you back a table, a new table with all those values. So remember the difference between selecting a single column and getting out a column with the dot column. Dot column gives you the array, and then you can start doing number stuff and weird cool things. But dot select gives you a new table that maybe you can attach new columns to and stuff like that. So there's a difference, okay? So only this one gives you back an array that you can then use and like call array things on. So that's fun. So the opposite of select was drop. You say drop, and then you say the columns you don't want in the output. So it'll give you a new table without those columns. So I don't know, cones with tax, again, be like, I want to see just the price with tax. I don't care about this old price anymore, so let me drop it. Drop the price. Boop. And so I got rid of it. I just see the price with tax column now. All right, so remember that this makes a new table, as usual. Does not mess with the old table. Cones with tax still has the price column, but by saying dot drop, this gives me back a new table having performed that operation of getting rid of the price column. All right, which I can assign that back to a new table name like cones with tax only or something, call it something, but it'll always give you back a new table when you drop and also when you select. Okay, so that select and drop and column, at least coming back to us. Any questions about any of that? So you can use indices pretty much always instead of label names, if that's easier. It's often quicker to use indices, but at the expense of like knowing what you're doing. It's a lot clearer to say select flavor price with tax rather than select 0, 3. You kind of have to do some more mental effort to figure out like what was I doing with 0 and 3? What did those mean? Whereas this makes a whole lot more sense. So it's up to you which one you prefer, but probably spelling it out is right for now. We also know about sort. I'm just gonna keep going through ones that we've seen before until you have a question. Please shout out. So sort. You got a table, you say sort on it, you give a name or an index of a column to sort by, and then you can say optional at the end, you say descending equals false. So by default, descending is true, so you don't have to say anything. That means, let's see, oh sorry, the default is descending is false, so excuse me. So if you don't say anything about the word descending, when you sort, it's going to be ascending. The default is descending equals false, which implies ascending. And then if you want to, you can change this default to say descending equals true, and you provide that, and then it will actually sort top to bottom, like descending. All right, descending, not ascending. So that's an optional thing you can give to sort. Okay, so I can say cones with tax, sort by, well, here's the original table, right? Here's the original table. If I sort by the price with tax, by default, descending is false. So that means it's going to be ascending, price with tax. So cheapest to most expensive, but maybe, I don't know, you just got paid and you want to buy the most expensive ice cream cone at the store. And so you'll sort by descending equals true. So if you provide this, it will sort descending. So I get the most expensive cones first and then down to the cheapest ones. Okay. But yeah, always when we do this, it gives you back a new table. We have not messed with the original one, like the orders of the rows or anything. We didn't get rid of anything. Everything is as it was. The only thing that modified the table was that format thing, where we changed the way the price with tax column gets displayed to us. Like that always holds until we say something different. But that's pretty minor. So that's sorting. Ascending is you say nothing. Say nothing at all. And then descending is you say descending equals true. All right. You could also just say true, but I like to say descending equals true. That's how the book teaches. I think that's useful. So yeah. Dun, dun, dun. What else do I want to do? Are we ready for one we have not seen yet before? Questions before we get to it. So yeah, they're all in, everyone under the sun is in one of these pages, so please look them up. Try to play around. I think that's a great way to learn. The next one I want to teach us is called take. You say you got a table's name, you say dot take, and then you can give and comma separate a bunch of indices. Finally, you could do something with rows. This is a row-based operation. All right, we've only been doing column-based things up until now. So this, you say which rows you want. You can exclude, really you're including and implicitly excluding some rows of your table. Remember, the rows are just the horizontal, they're individuals. So you can see which one you want. You can give a bunch of ints, all right, a bunch of indices of the things you would like. So, and it gives you back a copy with only those rows. So let me show you what I mean by that. You can also just give one, like I want just this row only, please. So cones with tax. So here's the original table. The rows have indices too. So this is row 0. This strawberry pink 355. This is row 1. This is row 2, row 3. Yeah, row 4, row 5, row 6. So I can say I really want 0, 1, 2, 3. I want this strawberry one. That's row index 4. So I can say dot take 4. And what that will do is it will give me back a new table with all the columns, but only the row that I put in there. And you can make a bunch of, you can put a bunch of rows in there. You don't have to say just one. You can say, I want a few of them. I want index 1, I want index 3, I want index 5, and that will give me all these. 0, 1, 3, 4, 5. All those guys are going to appear there. Okay? That's comes with text. So that's dot take. This is a row-based operation. It's giving you back the rows you ask about with all the column information. So that's kind of neat. Yeah, does that make enough sense? Instead of hard coding all the indices you want, you can also generate the indices you want and pass an array of those indices that you care about. What I mean by that is, again, I've already done it, but just to remind you, we need the NumPy library for what I'm about to do. You remember with the NumPy library, you could say np.arange stuff. You can make a bunch of values. So you could say, I would really like all of the odd indices from this table. I want to get only the odd index rows. So 0, 1, that one, that one, and that one. That was my 1, 3, 5. So another way to say that would be this. Let's generate the 1, 3, 5 by doing np.arange. Go from 1 to, I don't know, 7. Up by 2s. Yeah, that will generate the 1, 3, 5 for me. The array 1, 3, 5. And then I can say take with that array as the argument. So I can generate with an A range the indices I want, and it will give me back those indices. And if you want every single odd index, instead of like hard coding the 7, I could say, what is 7? It's the number of rows, cones with tax.num rows. So even if there were 1,000,000 rows, what this would do, this line right here, would give me back all of the odd indices. Does that make sense? All the odd indices. So you could generate the indices you care about. And this will always work regardless of how big that table is. Does that make sense? Because like we're using the variable num rows. The table knows how many rows it had. If the num rows was 1,000,000, that would be replaced with 1,000,000. And that is always an index that doesn't exist. So that's a good stopping point. Go up to and not including that one. Yeah. Because if there are 7 things, right, there's 7 things in this table, the last index is index 6. So we never go up to index 7. So 7 is a good stopping point for an A range, which is cool and fun to think about. Any questions about that? That's a fun idea, I hope you see. So you can easily generate the indices you care about and then go to them. Take those ones. Give me just those rows, please. Let's see. I think, yeah, the place I'm trying to go, the last place I want to go really, is the most powerful one that we were talking about before, that I only showed you one piece of, that dot where. I claim that that's the most powerful thing you can do with tables, because it's going to filter out a table based on a question that you ask. So, are we ready for that? Any questions about anything else before we go to dot where? Because dot where is the most complicated one. All right, let's do it. One last thing we can do is we've got cones with tax, and we built it from the cones table, right? Cones is the old one without the tax. If we never need cones again, like cones with tax is like objectively better than cones. We never, like, there's a lot of typing. You can say cones equals. You can always overwrite cones with tax, right? So remember, but then cones goes away. Remember that you can always overwrite an existing table. So now instead of saying cones with tax all day long, now I could just say cones, and it's that one too. Yeah. So you can always overwrite stuff with the assignment. But yeah. Now let's do dot where. All right. Let's do dot where. So dot where, you give it a column label. You say, yeah, I got a table. Table dot, table's name dot where. You say the column label, and then you give what's called a predicate, which is just a fancy word for question. And it's going to give you the rows. It's again a row-based operation. It's going to give you back the rows that match the predicate, where the answer for the question is true, right? Because true means yes in Python. And the way you ask a question is you say something weird with the word R. That's just how they made the library. I think it's weird and silly, but you'll get used to it. You say R dot, and then one of the pre-approved words that they put inside of the R variable, and then you give it some arguments to say what you're talking about, and I'll show you that in a second. But for example, how you read this, if you didn't know, like if you didn't fully understand, you say, here's the name of the table, so cookies, give me all the cookies where the amount remaining column values are above 10. That's how you read it and understand it. Does that make sense? Like that's how you'll think about the wheres. Give me all of, so this is some example table. So give me all the cookies where the column label 0 values are equal to chocolate chip. See how I'm reading that? That's how you think of it. That's how you create those where things. And here's all the things you can put inside of an R. You say R dot equal to, above something, above or equal to. It's very wordy, and I'm sorry. I don't even like the word that you have to say R. R below or equal to, between, and between means greater than or equal to X, and strictly less than Y, so it's just like the A range, including this one and excluding that one. Strictly between means not equal to either, exclusive of either, and then between or equal to is inclusive for both. Containing is fun, that's on strings. So something label values are containing a string. And then all of these have their opposites. You can always prefix with a not underscore, like where the values are not equal to this thing, are not above this thing. And so sometimes there's equivalence, sometimes you say not. But that is where, and an example, again, is worth a million words. But the place you find all these things, again, with more information, is those where predicates are down here. Are equal to, blah, blah, blah. Are above. So look at the list. Above or equal to. It has examples, and you better believe they're here too. Where predicates. Equal to, above or equal to, below. They're all there. And this is going to filter out rows of the table that match the predicate, for which the answer is yes. True. Okay? So let's do an example. So here's my cones table. It's got all those things. I can say, give me all the cones where, so these are rows, right? Give me all the cone rows, because every cone is a row, where the flavor column values for that cone, where the flavor column values are equal underscore to chocolate. Do you see what that's going to do? Can you imagine in your head what's about to happen? Let me press Shift Enter and let's see if it's going to be what you thought it was going to happen. I'm getting these three, right? The ones with chocolate. Does that make sense? Are there any questions about what that's doing? So I'm saying, give me all the cones where the flavor column values are equal to chocolate. It's a little wordy, but you'll get used to it. That's how you read it, and that's how you understand it. And it's going to pick out just the columns, or just the rows that have chocolate for the flavor. So we ask for where it's equal to that. Yes? And all the other ones are similar to that. Does that make sense? All right. This is actually the default though. So if you just say, this is what we were talking about last time when I showed you the dot where it was just this one. If you say just flavor comma chocolate, the default is r dot equal to. That is the default. So if you say that, it's shorthand for the thing we did above. So by default, you get r equal to, because that's like the most common one you ever want to use. By default, you get an equality check. This is equivalent to the line above. Okay? And so, yeah, this is shorthand. Or the above. I just said the same thing twice, but who cares? Okay, that's the idea. Okay, so you ready for some other ones? So yeah, here's all the options. Let's use some other ones. Let's do, I don't know, below or equal to means just less than or equal to. Why did they not say less than or equal to? I'm not sure. They chose that. So here's my cones table again. Let's get, I don't know, let's say that I look in my pocket, I only have a $5 bill. I want to get an ice cream cone. So I can ask, which cones can I buy? By saying cones where the final price with tax, where the price with tax values are below or equal to $5. Yeah? Below or equal to 5. If you type tab, it will autocomplete after you've started typing a little bit, so that's helpful here. 5. And these will give me all of the cones where the price with tax values are below or equal to 5. Does that make sense? How I'm reading that? How it's understanding of that? And so these are the cones that I can buy with the money in my pocket. That's how you can think of it. Okay? So it's useful to be able to ask these questions. I hope you can see. So you can do some really cool stuff with all that. I think that is a good start. And then once you've done this, you can chain more table operations, right? We did that before, and I want to make sure that that is still clear, because this always gives back a new table. Like this whole thing is a table, and I can say dot more table stuff, right? So, I don't know, maybe I want to see this in order from cheapest to most expensive, so I could start sorting, couldn't I? I could start sorting by the price with tax. Ascending. So this will change it to have the vanilla one come first, because that's the cheapest one in terms of price with tax and price, because price with tax was based on price. Does that make sense? I do this first, it gives me a table. Then I start doing stuff with that table. It gives me a new table. And I can keep on chaining all that all day long. Any questions about that? So those are your kind of numerical operations. I hope those make sense. Like below, like read this. Above or equal to makes sense, right? Above is greater than, above or equal to is greater than or equal to. Like they're all there. Some of these are a little bit weirder. Let's talk about the string one. Containing is not numbers, it's strings. So where the values are containing a string. So this is where you have columns that are strings. So we have the flavor column is a bunch of strings and the color column is a bunch of strings. So I could do containing in either of those. I could ask about either of those. So let's do, just so we have the whole cones table. There it is. Let's do, I don't know. I want all the different chocolates, and let's think about it in terms of give me all of the cones where the ice cream color is some kind of brown. All right, so a way to ask that would be cones.where the color column values are containing the string brown. Does that make sense? And so that'll give me all of these. I could have just asked for chocolate, but if that's the way you thought of the question, that's the way you can ask the question. So where all the values are containing brown. So like this is a bigger string. It's light space brown, dark space brown, but brown is in it somewhere. That's what that question is asking. That's what that predicate is trying to figure out. All right, so you're getting back the rows with brown somewhere in the color. Okay? Cool. Let's see. Questions about any of that? So yeah, just try them all out. I think that's a good way to practice. Go to one of these documentation pages. Try out all of these on like the cones table or some other table that you like. Pokemon table, for example. I'll force us to use the Pokemon table, maybe. In just a second. I think this is a good start. Should we do any others? Yeah, I think that's as much as I want to say for .where. I want you to play around in just a second, and I'll give you time for that. But I think the last thing that I want to show is the .show. So let's remember .show one last time. So if you have a table, say .show. If you give nothing, it will show you the whole table, even if there were 1,000,000 rows. By default, when you print a table, it only shows you 10 rows, but you can control that with a .show. You can say .show, give me just 3, please. And so that's that. So cones, if you just say the name of the table, it will print the first 10 rows of the table. And if there's less than that, it'll print the whole table, of course. But if you just want a few, or you want to control the default of 10 to be something different, you say cones.show, and you can say like 3, all right? And what this will do is it will show the first 3 rows, okay? So it shows the first 3 rows. You say .show without anything, without a number. .show with nothing shows everything. All right, and so that's useful when you have like, I've got a 20-row table, just show me the whole thing, please. So you just say .show, and that is useful. You could also think about it as .show with nothing is shorthand for .show, name of the table, .numRows. Yeah? Because that would be the same, that would be equivalent. Yeah, I think that's most of what I wanted to say. Are we ready for an example on a different data set where I ask you questions? Ready to try it? Let me give you all this code first, or let me set it up and then give you all the code in just a second. I would like to have us play around with the Pokemon data set, because that's the default one that I've got on that Jupyter page if you want to go click on it. So let's read in the Pokemon table. And let's ask some questions about it. I've got some questions for you, and we'll go from there. So here's my questions for you. So get that Pokemon data set. I'll read it in together with us, but read it into a table, and then I would like you to try to come up with some questions about the Pokemon data set. I think that would be fun. And come up with like 2 questions, like with the people sitting next to you, that you would like to answer about the Pokemon table using your current knowledge of the things in it. And then maybe we'll pick some of your ideas and we'll do them together. So here, let's get the table together, and then I'll show you where you can like put your ideas so we can all see them. But here's my thought. Dividing line, let me get that Pokemon table, equals table, read table, CSV, Pokemon, Boop. So we can do a lot of things on tables now. It's very exciting. And then here's the Pokemon. You got all these different rows and things. There's a bunch of things involved. And let's ask some questions about these rows or these columns. So I've got every Pokemon up to a certain generation in here with their like attack and defense values and all these different things. Their HP at level whatever, probably 50 or something. And you got all these values, all these like here are their moves or something. That's abilities. So that's the Pokemon table. So please read that in. And what I'd like you to do is, as a group, here I've got it in the. I think that's all of us. I'll stop the attendance. I have made a fun page for us. It's called the Written Ice page. That's where I can ask you written questions where you give answers and you can post them. So what you can do is, I think I've got nothing in there, but as a group, you can like elect a leader and you can write a little post. You can post in your ideas right here. And then you can click submit and then we can all see them. And then we can take from your ideas and we can try to answer them together. All right. So my question for you is look at the Pokemon table. Think of some questions that you know how to maybe answer, but maybe it seems overwhelming. But write down your questions for the things that you might want to ask, and like knowing that like you might be able to do it with like your knowledge of tables, the arrays, because you can get out a column, get out a couple columns. But yeah, think of some ideas. Discuss with your neighbors what sounds interesting to you. Please write them down on this page and post them. And you can edit your post if you think of more, of course. And yeah, try to if you get a head start, you can try to answer them yourself. But I just want to see them, and we can do them together up here. Sound good? Questions about any of that? So yeah, read in that, get some ideas, post them. You can like elect a leader of the group to post if you'd like. But I'd like to see what you're thinking about, and we'll do them together.
Pokemon sucks. Two. With this says two. It's I think the highest now would be.
I think it would be the lowest amount.
No, Bulbasaur's beats the fire, and it says two, so it's. Bulbasaur's good.
So it would be the highest.
Yeah.
Against some. We could probably also add hands and stupid and all of the.
Ice for the water, makes sense.
You're all posted.
It's some way to. Okay, I don't have a big distance, but.
Why not get two?
I posted first.
Yeah, write down your ideas. You can think about how to ask them. Try it out yourself, but I want to see your ideas first. Just got one in there. Good. Yeah, try to come up with 2 good questions. At least 2 good questions.
We didn't actually. What, do you have an idea?
If you have questions,
The loser, the hunter. No, we could just do it. That's too easy.
I'll give you another minute to press submit. We'll try stuff together. I've got some ideas too.
I don't know. I don't know enough about Pokemon to understand what you just said.
I had a phase, okay.
Find out which Pokemon or
More legendaries by generation.
you had like a Final Fantasy table.
3.
My favorite game. It's like it was when they were trying to learn how to do Pokemon combat, and so it sucks. But it means that when you attack, there's a certain amount of seconds that you have to really like the attack is finishing, and you can't like cut your attack short and chain it really fast. And so probably the seconds between that would be something really cool to know. I haven't played all of them, so I like a specific subsection.
Yeah.
I like 13 with 15.
How many of them are there?
Oh, there's a lot. And then I also like the 7 series as well. But not the new ones, I just must have. So it's wearing now. I don't like the game. I don't like it.
All right, let's come back together. Let's see what we're thinking. Press that submit button. This is completely unrelated, but did you guys know that there's a Fresno Nightcrawler Build-A-Bear? Did you guys hear about that? That's so exciting.
I saw someone like recreating the way that they made like one of the videos though,
Yeah,
like a behind the scenes thing years later.
like the original. I'll have to watch that.
It wasn't the original, it was the second video.
Mm.
The recreators couldn't figure out how the first guys did it.
I think it was like a video of a video, right? It's extra blurry, so that was fun. Yeah, let's come together. Let's ask questions about Pokemon together. Let's see what we're doing here. Thank you for your thoughts, Group 3.
I'm the only one.
Apparently, press submit if you didn't press submit already. Your thoughts matter.
Friends out of the room, come join us.
Yeah, be friends. Nice.
There's hello.
There's so much news.
Next time. Our next question. Yeah. Well, let's do Group 3. So find the Pokemon with the most weaknesses by summing the against column. Oh, I like that. Then add a new column with their loser rating. And then sort descending weakest Pokemon. I like that. That's fun. How could we do that? Do we see an easy way? We kind of have to we have to extract all these againsts, right? And we just average them. Is that the idea? And is it higher numbers mean they're bad? I heard you guys talking about that. Higher numbers mean they're bad at more things. Okay, so an easy way to get all these columns at once would be, let's see, Pokemon.labels to get all their names really quick so we can copy and paste them. Here's all of the names against blah, blah, blah. We kind of have to extract all of them individually right now, wouldn't we? So we have to go dot column, get all those values, and we'd have to add them all together and then do an average. That would be a little disgusting, but it's worth trying.
How would you have to do an average?
Or what would you do, like? What would you prefer? You just want to sum them up? That would work too, I guess. Because yeah, still the smallest or like the biggest number would be they're still weak. So yeah, either average. I guess what is an average but a scaled sum? So that makes a lot of sense. So I need to get out all of those. It's easier if we had more things under our belt, but there's ways to make this happen. Here, let me cheat a little bit and use a text editor that will help me. So let's I want each of those columns from the Pokemon table. So here's what I'm going to do. I would like do I want these commas right now? So get rid of the commas. So I would like to, okay, what do I want? I want to go to, for each of these, it's in the Pokemon table. Pokemon, give me that column with that name. Boop, boop, boop. And I want to add it to every other one of those columns, right? Okay. Cool. Something like that. Yeah. Right? I want this. Disgusting. Would that work right now? No, it doesn't like me doing it this way. Would it work if I indented? It doesn't like it when I do it that way. When you have long, I guess, okay, let's just make it very disgusting. All one line. There. Whole thing. Go away. Yeah, look at those values. Okay. Nice, nice, nice. And then we want to add this back in. So like some values. Just call it that. And I want to put that into the Pokemon table.
Next to the name.
Yeah, let's actually select out just the name, and then I'll add this as as the second column of a table that looks normal. Add column. I don't know, what should I call this? Against? Against, yeah, loser rating. Okay, loser rating. Whatever you guys want. And we'll give it, call it summed values. And, oh, sorry. Pokemon.select. Oh, sorry, it's underscore, lowercase name. What? Table? Oh, with column, excuse me. It's been a whole semester. There we go. So here's the new table, which we can then sort descending, right? Because bigger numbers mean they're bigger losers. Sort by loser rating. Descending equals true. Ooh, I don't know about these ones. These are in like a later generation. So give me the generation too. I don't know which one of these are. Is it gen? Or is it generation?
More is rock types, so that makes sense.
Okay, yeah, we can also select out their primary type. Type 1. So yeah, rock. Type 2. Generation. Okay, like 6th generation Pokemon weren't doing that well. Sorry, you guys. And you got some bug Pokemon. I guess it makes sense for bugs to be squishable. So that's good to know. Nice. So yeah, it's bug and grass. You can also show, you can do a dot show, right? With,
This other 7.
give me 25 or something. 25 of them. Okay.
And you could do ascending for like.
Yeah, the most powerful one, you do ascending. Exactly. I'll have you guys try that one. But does the idea make sense, right? See how we're doing it? We're chaining ideas together like that. This is very disgusting code, but it gives us the answer, and that's all you want at the end of the day. That's a great question. Nice. Let's do one from the other group. Let me come back to this other one. Percentage of legendary Pokemon to regular Pokemon per generation. I like that a lot. Nice. That was you guys over there, right? That's a great question. Let's see. How would we find that? So I got our Pokemon table. What do I want here? One nice thing that you could do is you make a temporary table with just the things you care about, and then you can work with that one. So maybe we'll try that here. Now, percentage of legendary Pokemon to regular Pokemon per generation. So yeah, let's just do it for like the first 3 generations maybe. So it's Pokemon. Let's select out. We've got let's just do their name for fun. And then we've got is legendary, right? At the very end, is legendary. And we'll do their generation as well. And I kind of want to work with this kind of table, right? That's easier to work with. Let's call that temp or something. That's the table I want to start with. Call that temp. That would work. You always give yourself a temporary table. And then what can I do to it? I can go through it and I can get at the different generations. I can do temp now dot where. Let's do where the generation is 1, where the generation values are dot equal to 1, or just 1 by itself is the default, right? Let's spell it out for the first one. R equal to 1. And so here's all the generation 1 Pokemon. And then we can filter out how many of them are legendary by asking, I don't know, this is all of Gen 1. We can call this Gen 1. We could say, we can ask how many are there total, Gen 1, that would be num rows, right? There's 151 Gen 1 Pokemon. And then how many legendary Gen 1 Pokemon are there? We could ask by doing something like Gen 1 dot where. Let's look at it again. Here's Gen 1. Gen 1 dot where is legendary is a 1. Where the is legendary values are equal to a 1. And I spelled where wrong. Nice. So there's just a few of them. And to get how many, for percentages purposes, we could do a dot num rows on that, couldn't we? See how we could chain those ideas? Nice. Did you guys try it already? Did you get the answers? Was this the way you thought about how to do it? You did did it a different way. So there's multiple ways. So you could do that, divide by Gen 1 dot num rows. It's that's the percentage of legendary for Gen 1 Pokemon. Does that make sense? Questions about that? And so you could do it for Gen 2 in a similar way. It would get a little... I could try to do this all in one place, I don't know. Let's say which generation do I care about right now? Which gen? Let's work with 2. Where the generation, I think it'd be the generation I care about is my temporary table where the generation values are equal to which gen. Then you can change this up and rerun it with different ones. And then I could say gen where the legendary is 1 divided by gen numbers. So this would work for any generation now if I just change this. Does that make sense? There's for 1, there's for 2, for 3, you just change that to 3. And just go through them all that way. That's one way to do it. Looks like Generation 3 had quite a few more legendary Pokemon. Maybe people were getting bored of the franchise. They wanted to make a bunch of cool Pokemon. Who knows? Those are some good thoughts. Nice. Nice. Any questions about how I'm thinking about these things? Because I just want to try to show you my thought process and have that go into your brains. That's how we learn things. Yeah, we do the last one. Which Pokemon are dual attackers or legendaries by generation? Similar kind of question, maybe. Nice. So yeah, I think we kind of already answered that. So you can try more there. But let's see. Do I have some examples I wanted to try? We could do... I don't know. We could do the biggest Pokemon. That's a question I had in a previous semester. Yeah. So we can go into the Pokemon table and figure out which one would help us here. We've got it's the height in meters. So we can select that out. Select. We got name. We've got height in meters. And that's all I really need to do my work with. So let's call that table temp now. So my little temp table I want to work with. And I would like to go and we can just like do a sort, right? We can do a sort. Temp.where, the height, meter values. Oh, we don't even need a dot where, we just sort. No, this is an easy one. Sort height, meters, descending equals true. Show me like the top 5 or something. Like you could chain the, oh, this is useful. Okay, I did need the dot where. Perfect. Sometimes you have missing values, and those are called nans. It's short for not a number. That's part of the table. So sometimes there's missing values, and those are represented as things called nan. And when they don't exist, you can filter out the nans by doing it this way. Let's see. That's wonderful. That's actually very useful for me. Can I see any nans very quickly? Show 25. No, it looks like, oh yeah, like some of these don't have a height. Some of these don't have height. So we want to get rid of those. I don't know why. I wonder, these are rat Pokemon, like they burrow into the ground, they have no height. Or it's like somebody forgot to put it in. But they're small anyway, so it's not going to be part of our answer. So one way to get rid of them is you can just filter, you can do a dot where. A nan fails every check for like numerical things. So you can do like a dot where, like the height in meters values like are above or equal to 0. If you do that, that's going to get rid of all the nans because it's going to fail that check. And then you could sort, and yes, the whale one is the biggest. It's 14.5 meters tall. That's pretty big. 1, 2, 3. It's like bigger than this room, right? Yeah. That's fun. Cool. So yeah, that's a question. What's another question I got in the previous semester? Let me scroll through. Oh, a fun one was the a student asked about the speed to weight ratio of a Pokemon. Just fun. Let's try that. Dun, dun, dun. So let's see. Oh yeah, let's just like remember what nan meant, by the way. Don't want to write that here. Or no, let's do it. I think I'll get a nan in this one anyway. So I could do Pokemon. I've got speed, and it's just called speed, I think, which is in the S's. We've got speed, and we've got weight. Weight underscore kg. That's what I care about. All right, so my temporary table this time. Give me the name of the Pokemon, the speed, and the weight kg. That's what I care about. And honestly, onto that I can attach, right, a column. With a column, what do I want to put there? Let's make the speed to weight ratio. Ratio with, and you can do math, right? You can do math on the column. So you can get at the column, get the speed column, divide it by the weight column. That would totally work. So Pokemon dot column speed. Give me all those in that order. Divide by Pokemon dot column weight underscore kg. Cool, and there's my temp table now. It's got these ratios, which is useful. And then, again, we could do a sorting. We could do temp dot sort by speed to weight ratio, and I don't want to type that, so here's a good example of when to use an index, 0, 1, 2, 3, sort by column 3, and then descending. So which ones have the highest speed to weight ratio? They're the most efficient. And I get some more nans. So nan just means I didn't have that value, like there was no weight for this Pokemon for some reason, like maybe like that fluctuates or something, like it's random. So they didn't want to include one for these particular Pokemon. So we have some missing data, and so let's spell it out. So nan is short for not a number. That's a useful word. It's just a value that is a placeholder for nothingness. Placeholder for I don't know. And this will happen a whole lot in like real life data sets that you may get one day as a data scientist. You can choose to filter, you can choose to replace with an average value, some temporary thing, it's up to you. But to get rid of the nans, you can use a dot where to get rid of nans, because nans will fail any check that you could ever do, because nothing works for a nan. So you say temp.where first, then you can sort. Temp.where I don't know, you could sort by, you could do any of them. Like, let's do the speed to weight ratios. Where the speed to weight ratio is not a nan, so like where the values are, again, above or equal to 0, because like every ratio is going to be at least bigger than or equal to 0. And we want them descending anyway. And so here we go. It looks like, oh, the ghost Pokemon, that makes a lot of sense. They have no weight. They're so tiny, but they're very fast. Okay, so that makes sense. They have the biggest speed to weight ratio, and I don't know any of the other ones because I only played up to Generation 3. Cool. But yeah, that's Nan. I think that's some examples that I wanted to see. Dun, dun, dun. Yeah, I think I have, let's see, 2 more quick examples just to make sure I always have them here that were good ones from like the first semester I taught the class, and then we'll go from there. Then I'll give us time to work. So, okay, last question. I want to remember it, or I think 2 more questions. How does the speed of Pokemon that are more likely to be female compare to the speed of Pokemon that are more likely to be male? This will show that the Pokemon Company is a little bit sexist. So that's one question that's cool. And then one more question. Let's see, do I want to do that one? No, I think we're good. I'll just do this one. So let's play with this one. I think that's a fun one, and that will be that. So here's my Pokemon table again. You can get the percentage, I think it's percentage male or percentage female? Percentage male. That's how often these Pokemon are male, and so if you subtract from 100 that, it'll give you the percentage that they are female then when you encounter them in the wild. And so my temp little table can be Pokemon dot select name percentage male and speed. I guess the game was originally created for like young boy audience, which makes a lot of sense, but they have since changed that, of course. And so here's the data I care about, and then I can get the percentage female by like taking this column and changing it a little bit, right? I can be like, all right, I got my temp table. Let's add a column called percentage female. And I can get that by taking 100 and subtracting from 100 the column called percentage male. Does that make sense? Like I can do that math and it'll be happy. And then I've got that column sitting right there, and that's useful. And like I want to work with this, let's call that temp now. So like I can overwrite temp with something based on it, which is fun. It's like that's temp now. Cool. And then I can do my question is, we want speed. We want speed as well. So let's see how that compares first. We can explore the data. Temp.where, I don't know, the percentage female values are above 50. So greater than 50 means these Pokemon are more likely to be encountered as female. So like you see both usually. Look at them. Some of them are 100% always female. Some of them have a lot going on there and are more often like that. And then here's what we can do. This is one way to get all of the Pokemon that are more likely to be female, right? So we can start with them. And we can be like, what is their average speed? Because that would show me something about all of them at once. Get all of their speeds and take the average. So like get the column called speed. And this is like the column for speed of all of the Pokemon who are more likely to be female. There they all are. They're their speeds. And I can take the average by dot mean is one way to do it, right? So their speed is on average 66-ish. And then the other one, we can do the same for percentage male, right? Where those values are like the Pokemon that are more likely to be male, above 50, give me their average speeds. And it's a little bit faster, which implies that Pokemon, the company, was sexist, at least for a couple years. That's exciting and interesting, and we've concluded that. We've explored the data. So does it make sense how I answer that question? I think it's an interesting question. And yeah, you could totally think about this like in the real life. Like you could do this on data for people and see like what is the difference. That's really cool. That's really cool and exciting for like funding purposes to make sure that like the school is funding things properly or something. Get the data sets. So yeah, I think that's where I want to stop for the day. Are there any questions about anything that we talked about? I'll give you all this code, of course, and remember to take your break whenever you want it. But the last thing that I want to do before I let us take a break is I have now covered all the things we need for these 3 assignments. So it's up through this chapter. We're gonna practice with the things that we know next time because we learned so many new things today, like a bunch of new words and things. So we're just gonna practice table stuff and array stuff next time. So it'll just be we're gonna go over stuff, but I can give us due dates for all of these assignments now, and it's gonna be in this order. So I always want to give us at least a week to do stuff, and I think Wednesdays and Fridays are the due dates that I like. So Lab 2, Homework 2, Lab 3. Scroll. So Lab 2, then Homework 2, then Lab 3, in that order. And let's see when things are already due. Make sure I don't like double dip. I think we got something due today, right? So Lab 1's due today, so got a few more minutes to ask me questions once I release us. So yeah, it looks like I can do next Wednesday, so the 26th can be the first one, and then we can do the Friday, the 28th for the next one, and then the 2nd of September for the one after that. So 26th, 28th, and the 2nd for each of those. All right, so that will be the date. 26, and it's going to be 5. I'll change that in a second. Remember, the due time is always 5. So then the 28th, and then September 2nd. And these are all going to be due at 5 p.m. 5 p.m. And they're already out there, but now they have due dates. I think that is everything. I refresh this. Now you got those dates in there. Yay. Okay, so that's where we're gonna stop. We can have like I'll leave us a little note to remind myself that this is where we stopped. So, like to be continued. And yeah, we're just gonna practice all this stuff next time. And so the rest of the time is now all yours to work and to ask questions and to take your break whenever you want to. I'll be here trying to get you all this stuff in between your questions. Oh, and I don't need to be recording it.